Okay. So we are on page 7 of Unit 6. We are starting lesson 2 here, and we're going to start with some warm-up problems. We're probably not going to do all of them, but just a couple of them so that you get an idea of how substitution kind of works or just how regular algebra works so that we can use that for substitution. Okay. So if we're on page 7 and we're all at number 1 here, we see that we have 3x plus 16 equals -5. Okay, so these warm-up problems here are not substitution, right? These are just trying to get us into the habits that we need to use for substitution. So how am I going to get x by itself? What's my first step? Yeah, I'm going to subtract 16, right? Whatever I do to one side, have to do the other. So I'm going to be left with 3x equals, and again, think of it like combining like terms, right? What's -5 plus -16? -21, right? And then how do I undo multiplication right here? Divide, right? Going to divide both sides by 3. My x is going to give me -7, right? And essentially what this x value is that if I plugged in -7 right here for my x, this side is going to give me -5, and it's going to be equal to -5 on the other side, right? That's what solving equations is. You want to find the missing value of the equation or the expression there, okay? If I take a look at this one, what's my first step? What should I do? Any ideas? Okay, so let's start by subtracting 7x. Again, when we have multi-step equations, I will usually try to move the x variable from the right to the left. You can algebraically do it the other way too, right? I could have subtracted x over, but again, just so that we're all on the same page, let's subtract from the right to the left. So that's going to cause those to cancel out, right? 7 minus 7 is 0. And over here, I'm left with -6x minus 27 equals -15. Okay, this looks exactly like the last problem. So what do I do next? Yep, I'm going to add 27. Again, whatever you do to one side, you have to do the other. Because when we're working through equations, we're not just moving numbers around however we want to, right? I'm not just saying, oh, I'm just going to move all the numbers to the other side just for fun and do whatever I want with them, right? Essentially, if you're getting rid of it from one side, you're able to just move it to the other side, right? We're not increasing the value of anything. We're just changing the location of it, okay? So now we have -6x equals, is this 13, 12? Okay. So +12. And when I divide by that -6 right there, I get -2 for my x, and we're all set. Okay. All right. Let's look at this last one, and then we'll move on to substitution. Okay. Can I, what do I have to start with here? What do I have in front of my 2x minus 9? I do have a parentheses, yes. I have a -1. And Jason, what you mentioned, no, you're right. With the parentheses, that means we have to distribute, right? We can't do anything until we multiply this -1 into both of our terms. Does everybody remember how to distribute, right? You multiply that outside term into each of the inside. So I'm going to bring down my 6x for now, right? Nothing's going to change there. Because what's -1 times 2x? Yes, -2x. What's -1 times -9? +9. I feel like I sort of gave it away there. Okay. All right. At this point, does everybody see how we can combine like terms here? We have 6x minus 2x. What does that give me? 4x plus 9 equals -31. And now we've got a problem just like the other two. Subtract 9 from both sides. That gives me -40. And when I divide by 4, I get x equals -10. Okay. So again, what this means is if I took a -10, plugged it in for both of these x's here on this left side, all of this would give me -31, okay? Because it's equal on both sides, okay? Does that make sense as we just did some of those warm-up problems? Okay. So what we just did there is what we're going to be doing a lot of in these problems, okay? So if you feel good about that, then these problems shouldn't be too bad. Okay. So solving systems of equations by substitution, essentially what we do, if you think of substitution, or I think the most common time you'll hear that is like a substitute teacher, right? You're taking out what's normally there and replacing it with something else, right? So you take out your normal teacher, you replace it with a substitute teacher. Same thing with substitution of this. We are replacing a variable with its known value. Okay. Another way you could say that is what it is equal to. Okay. So again, known value is just another way to say what it's equal to. Okay. So if I know x equals 3 plus y, I can plug that in for my x value. Okay. And we'll see that as we look at a few of these problems. Okay. So let's take a look at our steps to solve. And again, I'll try to leave that definition sort of up there so you can kind of keep writing, okay? All right, number one, look for an equation that's solved for an x or a y, okay? So that means we want to have x equals or y equals by itself for an equation. Does that make sense to everybody? We don't want to have multiple things all on one side. We want to have x equals or y equals, okay? So look for an equation that's solved like that. And then we want to substitute, again, that's the replacing the expression into the other one for that variable. We're going to solve so that we only have one variable left. And then we're going to put our answer into another equation to find our y or our x, depending on what we found, okay? So again, I know that I just read through those quickly. Once we go through a problem, I think you guys will see the method, the steps that we take, okay? So looking at number one, are either of my equations solved for x or y? Yes, they both are, right? They both have y's by themselves. So what this means is I can use either of these and I'm going to substitute it into the other equation, okay? So I'm going to use this equation right here just because it has, I guess, smaller numbers. Either way, it's going to look pretty much the same. Does everybody see how y equals x minus 9? Okay, I know that sounds silly to say, but what I want you to really understand is that if y equals x minus 9, I can just plug it in right here for y, right? I can take what I have here and just plug it in for y. And the reason I can do that is because that's what y equals. Y equals x minus 9. So I can just plug it in right here, okay? So x minus 9 equals 4x minus 24, okay? Again, does everybody see why I could do that? Because y equals x minus 9. So I can just plug it right in for y. Yeah.
Can you do it in reverse if you wanted to?
If I wanted to take this and plug it in up here, absolutely. Yep. You can't always do that, but if you have a problem that both has y equals this, y equals that, you can totally do it in reverse. If you did it in reverse on a different problem, it wouldn't be as simple as doing the quick reverse. But for a problem like this, absolutely. Okay. And do you guys see that now all we have is x's? So now we can actually solve for x. Because up here, I can't solve for x or y. I can't figure out what x and y are because I have two variables in a problem. We haven't learned how to do that, right? Algebraically, you can't find out both variables without having some outside information. So what we can do is we can substitute so that now we have only x's. So we can find out what x is, okay? So you guys, do you see how this now looks just like number 2 up here? So let's do this problem. How do I get x by itself? What's my first step? Remember how we're moving x over? Yep. So let's start by subtracting 4x on both sides. That's going to give me negative 3x minus 9 equals negative 24. And now you guys should see that we know how to work through this, right? Let's add 9 to both sides. What does that give me? Is it negative 13? Or no, negative 15? Is it negative 15? Okay. Thank you guys. So negative 15. And then again, to undo that multiplication, I'm going to divide by that negative 3. So that's going to give me x equals positive 5. Does everybody see that? Does that make sense how we got that for now? Okay. And we're going to do more examples of this, of course. Okay. Remember how systems of equations are an XY pair, right? So this isn't the whole answer. This is my X value, but I still need to find my Y. Okay. If I know X is 5, I can just plug it into either one of these equations. Which one do you think will be easier to find Y? Probably the top one, right? So Y equals 5 minus 9. You guys, what's 5 minus 9? -4, okay? So my Y is -4, and I'm done, okay? So these two problems, or these two equations right here, this system of equations, you guys, you could absolutely graph these as well, right? But do you really want to graph a -24 on the y-axis, right? That's you'd have a huge graph. So when you have really big numbers, you can just substitute them, right, to find out that x, y, where they intersect. Okay. Let's take a look at another one. Okay. Number 2, do you guys see how both of these are like y equals something, right? We don't need to rearrange them at all. We have y equals -x or -8x plus 14 and y equals -5x plus 11. So what I can do, since I know that y equals -8x plus 14, I can just substitute it in for that y. So instead of writing y, I'm going to write -8x plus 14, and I'm going to set it equal to -5x plus 11. Okay. So now this is just like the last one. I can solve for x. So what's my first step? How am I going to get my x's together? How do I move that -5x over? Yep. I'm going to add 5x to both sides. That's going to cause those to cancel off. That gives me -3x plus 14 equals 11. I can now do the inverse of addition, which is to subtract. This is going to give me -3 equals -3x. And when I divide by -3 to get my x by itself, I get +1. Okay. And again, that's only half my answer, right? I've got my 1. Which equation do you guys want to put that 1 into? Ultimately, it's going to work for either, right? I usually tend towards the one that has smaller numbers just because the multiplication's a little bit easier, the addition's a little bit easier, okay? So y equals -5 times x, we just said was 1, we just found that, plus 11. Okay, so I'm using this bottom equation this time to find out what my y value is. Okay, what's -5 times 1? Negative, yep. And then when I add 11, what do I get? +6, right? So that's my y value. It's +6. Okay. Does that make sense so far, you guys? What we're doing when we're substituting. Again, we're replacing a variable, right? So in this case, we've been replacing y with what we know it equals. Okay. And again, Lila mentioned it, and it's a great thing to know, is that I could have taken -5x plus 11 and plugged it in here. The only thing that would be different is that these two sides would be flipped, right? But you could still it would still equal 1, 6. Okay. So let's flip the page now. Let's take a look at some other problems. We'll try to get through as many as we can here. Okay. Okay, number 3. Do I have at least one equation that is x equals or y equals? Yes, right? Both of them don't have to be x equals or y equals, okay? For substitution, at least. Okay, so I know that y equals -2x minus 8, okay? Where am I plugging that in? I'm plugging it in for y, okay? So I need to plug that in right there. How does that look? Let's see. We've got -5x plus 4. My y is an entire -2x minus 8. Okay. So I'm plugging that whole thing in and putting it in parentheses. Okay. And then I want to bring along that 7 that I have at the end of my equation. Okay. So instead of having two things that are equal to each other like we did before, now we have something we need to distribute, right? Because we plugged it in for y. What's 4 times negative 2x? Negative 8x, right? 4 times negative 8 gives us, is it negative 32, right? And then I can bring down everything else. Okay. We can combine like terms, right? Negative 5 plus a negative 8 gives me negative 13x minus 32 equals 7. I can add 32 to move it to the other side. That gives me 39. And when I divide by negative 13, what do I get for my x value? What's 39 divided by negative 13? Yeah, negative 3. Okay. So again, that's only half my answer. I've got negative 3, and I have to look for my y. Again, I think that the easiest way to do this would be to use this bottom equation. Does that make sense? It's already solved for y. I don't have to rearrange anything. I just have to plug in my x. So y equals negative 2 times negative 3 is what we just said x was, minus 8. Okay? Negative 2 times negative 3, positive 6, minus 8 gives us negative 2. Okay? I know I went maybe a little bit faster there, but does that one make sense as we're working through it? Okay. So the big thing with this one is if you don't have two of them that are y equals, right, you're going to be plugging this in the middle of an equation, right? So when you do that, make sure you put parentheses around it, right? Put parentheses around this. Make sure that you distribute whatever term is in front of your y in that other equation. Okay. Let's take a look at, I want to move on just a little bit here. Let's do number 7. Okay, you guys, what is my x value of my answer? You guys should be able to tell me right now. Negative 3, right? Just like when we were graphing, if you have an equation that's x equals negative 3 or y equals something, it's giving you half your answer already. Okay? So when we substitute, this one's not too bad, right? All I'm doing is putting a negative 3 in for my x. Okay, so this one's a little bit different. Does everybody see how we're plugging in for the x this time instead of the y? It's because what we have on its own is an x equals equation. Okay, so you can do x's or y's. So let's plug that in. Now we've got 4 times negative 3 minus 9y equals negative 48. When I multiply this together, I get negative 12 minus 9y equals negative 48. To get 9y by itself, or to get y by itself eventually, I need to add 12 so that those cancel off. That gives me negative 36. And what do I get when I divide by negative 9? Can anyone help me out? Positive 4. Is it positive 4? Okay. So positive 4. And there's my answer. Okay. So some of these problems might go by a little bit quicker if it's just a single number that you're plugging in, right? Or some of them might take a little bit longer when you have to distribute and have it right in the middle of an equation. Okay. I want to take a look at two more. Okay, so 8 and 9 here. And then I will give you guys some to do for homework tonight. And again, I know that class is almost over, so I'm going to give you probably fewer problems to work through, but I want to make sure you guys practice this, okay? So if we look at number 8 here, we've got negative x minus y equals 1, and we've got y equals negative x plus 4. Okay, so identify the equation that has either y equals on its own or x equals. That would be this one, right? So what we're going to do is we're going to plug this in for my y. But remember, you guys, there's a negative 1 out front that I need to distribute. Okay, so don't just drop the negative. Let's rewrite it out. This top equation, now that we've substituted it in, we've got negative x minus negative x plus 4, right? That's what I just substituted in. The negative x plus 4 equals 1. Okay, so again, don't just drop that negative. We have to make sure we distribute it to both of our terms. So we've got negative x. What's negative 1 times negative 1? Positive 1x, right? I just want to make sure that we see that we need to multiply everything. Not that I know you guys know. Negative 1 times positive 4 gives us negative 4. And we've got positive 1. Okay. Does this one make sense? I know sometimes it's harder when there's just a bunch of ones. Like I get that that can be a tricky. Yeah. What's negative 1 plus 1? 0, right? Yeah. Do you guys see how these are not equal? Negative 1 does not equal, or sorry, negative 4 does not equal 1. So this is no solution. If this was graphed out, how would it look? What kind of lines are parallel lines, right? Yeah. So these would be parallel lines. Okay, if we were to actually graph them out. Okay, and this last one here, does everybody see that we have y equals right here on top? So what we're going to do is we're going to plug that in for our y right there. So we've got 2x minus 2, and instead of y, I'm going to write x minus 8, because that's what I substituted in. We can multiply that negative 2 into each of our terms. So 2x minus 2x plus 16 equals 16. Okay, 2 minus 2 is 0. Hopefully everybody agrees. We're left with 16 equals 16, which is true. So in this case, we have infinite solutions. So this would be two lines that are exactly the same. Okay. Does that make sense for substitution? You take what you know about one line and you plug it in or replace it into the other equation so that you only have one variable to solve for. Okay. So again, I'm not going to give you many problems. I'd like you guys to work on, I think the bell's going to ring any second, so please don't just pack up and run. Let's see here. I want you guys to do 1, 5, and 12. Okay. Does that make sense? Only 3 problems. Okay. Numbers 1, 3, and 12. Okay. Or sorry, 1, 5, and 12. Please come to class with those 3 done. And thank you guys for being respectful about the bell ringing and waiting.